Hello friends, welcome to this video, and in today's video we'll be seeing finding the majority element in a given array using two different techniques. One is using the dictionary and the other is sorting the array given initially and then finding the majority element. First, let's see the dictionary method of solving this. In the dictionary technique, it is very straightforward. The concept is very simple. We have this initial given array. We have to traverse each element in this given array, and then we need to check in this dictionary whether that element is present or not, and if it is present, then we should increment its count value, which represents the number of occurrences of the element inside this given array. And if it is not present, then we'll add its value to this dictionary and we'll set its count as 1. So that is very simple, and at any point of time, if we encounter that this element count is greater than this expected count n by 2, it means that this is the majority element. Because remember from our previous videos, the majority element is the element whose frequency of occurrence is greater than n by 2, where n is the length of this array. So here the length of the array is 5 and 5 by 2 is 2.5. So at least 3 should be the frequency of occurrence of any element in this given array to be qualified as the majority element. So let's see that. So first I will encounter this element 3. So 3 is not present in this map or a dictionary. So I will add this value 3 in the dictionary and I will set its count as 1. Then I will traverse further. I am encountering 3 again, so I will increment its value to 2. Then I will further traverse. I will encounter 4. So 4 is not present in this dictionary, so I will add 4 and I will set its count as 1. Then I will encounter 5. So 5 is not present in dictionary, so I will add 5 and I will set its count as 1. Then I will again encounter 3. So 3 is already present in this dictionary, so I should increment its count by 1, becomes 3. Now as soon as I see this element count is 3, I see that it meets our majority element criterion, so I will exit my program over here, returning this element as the majority element. So let us see that in action. Here is my method to find the majority element using an extra dictionary. The first variable is the expected count, which is represented for this value n by 2. Second, I define a map, hash map, which acts as my dictionary, wherein the key is the element itself and the value for the key is the element count. And then I will traverse this entire array A. This array I will traverse. For that I have written a for loop, and then I will check each element whether it is present in the dictionary. If it is contained in the dictionary, then what I will do is I will get this element count for that particular key value and I will add or increment its count by 1, and then I will check if the updated key count is greater than the expected count, which is nothing but greater than half of the length of the array. And if it is greater than our expected count, then we have met our majority element, so I will return that element, or else I will put that element in the dictionary with the updated key count. And if it is not present in the dictionary, then I will simply add it to the dictionary and I will set its count as 1. So that is very simple logic written here for finding the majority element using the dictionary. And at the end of our function, if we don't find any majority element, I'm returning majority element does not exist. And talking about the time complexity of this algorithm, it takes big O of n times, where n is the length of the array, because we are traversing the entire array only once. So it takes big O of n time complexity, and since we are using an extra map, it will take an extra auxiliary space of n elements, so auxiliary space complexity becomes big O of n. Let's run this program with our sample example which we have seen earlier. So here is my main method in which I have this array and I have invoked this find majority element from the dictionary class for this array A. and here is my output. It's printing majority element is 3. So that's about the dictionary method, and the sorting technique is also very straightforward and very simple. In the sorting technique, we initially sort this array, so this array becomes something like this after sorting. Now here we take two variables, one is the candidate element index and the other is the current count. It's similar to the mood sorting algorithm, but here since the array is already sorted, we need not do the plus minus logic of incrementing the current count. We will simply increment this current count while traversing the array, because we know that in the next consecutive element will be the similar element if it exists, or else it will be a different element. So let's see this example as well. So in the sorting technique, initially we sort this array, and then the candidate element index for the very first time will become the first element itself, so it will become 0, and the current count of this will become 1, and then we'll keep traversing to the next element. Okay, then we'll encounter 3 again, so we'll increment its count to 2, then we'll again encounter 3, so we'll increment its count to 3. So here we have found this current count to be 3, which is meeting our majority element criterion, so we'll exit the traversal further and we'll print out the majority element. Or else what we'll do is we will continue with the next element. We will set the candidate element index to that particular element index and will initialize its count back to 1 again. So here is my sorting technique. This is the expected count. Initially I sort the array A, and then I'll set the candidate element index to the very first element index. I'll set it count to 1, then I'll traverse the entire array and I will see if that particular candidate element index is met in my traversal. If yes, then I will increment the count of that particular element, and at any point of time if the count becomes greater than the expected count, that is the majority element, so I will print it and I will return or exit from this for loop. Or else if I meet a different element apart from the candidate element which I have chosen, I will set it as the candidate element. Okay, and I will initialize it count to 1, and the same process gets repeated for the second unique element as well until we find the majority element, and at the end I will print majority element doesn't exist because it has exited the for loop. So this is also very straightforward. And coming to the time complexity and space complexity, it depends upon the sorting algorithm we use over here. In my case, since we are using arrays.sort method, it uses dual pivot quicksort, so it takes big O of n log n time complexity and omega log n space complexity. Let's run this program for our example. So here it is printing majority element is 3. Yeah, so that's all for this video. We have seen two techniques. One is using the dictionary method and the other is using the sorting technique. So two techniques we have covered, the dictionary method and the sorting method for finding the majority element in a given array. So that's all for this video. Thanks for watching.